Welcome to this explainer. I am so thrilled you're here today because, well, we're going to look at a truly fascinating concept that's completely changing how we interact with artificial intelligence. We are talking about leveling up AI outputs through a super powerful, honestly, almost human-like technique called self-refined prompting. If you've ever felt like your AI assistant gave you a, let's say, slightly rough or maybe incomplete answer on a really complex task, this is exactly the explainer for you. We're going to explore how AI can actually critique and improve its very own work.
Here is a quick look at our agenda for today. We are going to cover 5 main areas: the first draft problem, what is self-refine, the 3-step process, measuring the performance boost, and finally, some limitations to consider. Let's get into it.
Starting right off with Section 1, the first draft problem, or why large language models stumble on complex tasks. So, large language models are incredibly capable, right? But they often hit this major friction point. When you give them a really intricate task, maybe something with multiple competing objectives or a vaguely defined goal, they tend to just rush it. Their initial output often includes inaccuracies, maybe some false ideas, or just completely lacks polish. Think about how we write to kind of understand this problem. When you need data from a colleague, your brain's very first draft might literally just be, send me the data ASAP. I mean, it gets the point across, sure. But then you pause, you give yourself a little feedback. You realize, wait, this is a work colleague, not my best friend, and I definitely need to be professional here. So you refine it to something like, hi, Ashley, could you please send me the data at your earliest convenience? We do this instinctively all the time. We draft, we self-critique, and then we refine. Which brings us to Section 2. What is self-refine? The concept of iterative improvement. What if we took that very human ability to pause, critique, and rewrite our own work and actually applied it directly to a large language model? Like, what if the AI didn't just hand you its blunt first draft, but actually refined its own solution first? Self-refined prompting is exactly that. It's an approach to improve initial outputs from LLMs through iterative self-feedback and refinement. And the absolute game changer here is that this happens without needing any labeled data or extra training. You don't need to go out and find a massive new data set to teach the AI to do this. You're simply leveraging the model's existing smarts, prompting it to generate its own feedback, and then asking it to enhance its own answers based on that exact feedback. It is incredibly efficient. Let's move to Section 3, the 3-step process, also known as the iterative feedback loop. Okay, let's transition from the theory into how we actually execute this technique in practice. How do you get your AI to do this right now? Well, it breaks down into a super simple 1-2-3 loop. Step 1, you prompt the model to get an initial output. Step 2, you pass that exact prompt and the initial output back to the model, and you specifically ask it for feedback. Step 3, you pass that feedback back to the model to get a refinement. And the beauty of this whole thing is that it's a continuous loop. You just keep going from step 2 to step 3, 2 to 3, over and over, until a specific stopping criteria is met. Let's actually walk through an example together. Imagine we're sitting side by side working on a coding project. Our initial prompt to the AI is just, generate a Python function that finds the greatest among 3 numbers. And the AI spits out this basic code. It's a standard if, elif, else block. It checks if number 1 is greater than the others, then number 2, then number 3. It works. For sure, it is perfectly functional. But honestly, as a developer looking at this, it's totally unpolished. This is basically the AI equivalent of that send me the data ASAP draft we talked about earlier. So we move to step 2. We ask the AI to give some easy-to-follow feedback on improving its own code's readability, quality, and runtime. Now notice the feedback the AI generates here. I'll read its exact response. The code is simple and easy to understand. Good job on that. One way to slightly improve its readability is by adding comments. Another improvement could be to update the last elif statement to elif num3 greater than or equal to num1 and num3 greater than or equal to num2 for consistency. It's wild, right? The AI is essentially playing the role of a senior developer, actively reviewing its own junior-level first draft. Now let's see how this builds in step 3. We literally just tell the AI to implement its own feedback, and this brilliantly illustrates the power of the technique. The AI seamlessly injects these clear, explanatory hash comments right before every single logic check. Plus, it fixes that dangling else statement at the bottom, converting it to a perfectly consistent elif statement, exactly like it advised itself to do. The readability and consistency are just instantly leveled up. But you might be wondering, how do we actually know when to stop this loop? Well, we just ask it for feedback one more time. And this time around, the AI replies with,
The code is easy to read and understand. There are no more improvements to make. This specific response acts as our stopping criteria. Once the AI can no longer find flaws or suggest any meaningful improvements, the iteration loop naturally ends, and you're left with your final, highly polished output.
All right, Section 4, Measuring the Performance Boost. Let's look at the data behind the method.
So this all makes total logical sense, but what does the actual data say? Does this workflow really create a measurable difference compared to just crossing our fingers and hoping the AI gets it right on the first try? The results are honestly staggering. When we look at the data from the source material, employing self-refined substantially boosts a powerful model like GPT-4, actually allowing it to outperform previous state-of-the-art baselines basically across the board. For code optimization, performance increases by 8.7 units. For code readability, just like the example we just went through, it jumps by a solid 13.9 units. And for really complex tasks like sentiment reversal, we see a massive 21.6 unit increase in performance. To put that into perspective, this isn't just some minor tweak. It is a huge, measurable leap in quality across highly diverse tasks.
Moving to our final section, Section 5, Limitations to Consider, or when self-refined falls short. Now, as genuinely enthusiastic as I am about this technique, it is absolutely crucial that we responsibly explore the boundaries here. Self-refine is not a magic wand for every single situation. Let's walk through a few specific limitations. First off, your base model has to be smart enough to actually handle this. It must be highly capable of following complex instructions. If you try this with a more primitive or older language model, it simply fails. It just gets totally confused by the loop. Second, the really impressive results we just looked at, those are based primarily on testing with English datasets, meaning the method is currently proven mostly on English text. And third, from a strict security standpoint, there's a real vulnerability where this iterative feedback loop could be intentionally steered by bad actors. They could feed it malicious refinement criteria to generate toxic or harmful text. So bottom line, it requires a highly capable model. It's currently English dominant in its proven results, and it absolutely carries security risks that developers need to safeguard against. And that brings us to the end of our explainer. We've seen how transforming a blunt, rough first draft into a polished masterpiece doesn't actually require extra training data, just a smart application of the self-refine loop. By asking the AI for an initial output, demanding feedback, and then enforcing a refinement, you unlock a vastly higher tier of performance. So, I want to leave you with this final thought. Take a look at the complex tasks on your desk today. What will you empower your AI to refine next? Thank you so much for joining me to explore this topic. Keep learning, keep experimenting, and I will see you in the next explainer.